This changes everything. We thought we knew about how powerful earthquakes can reshape our entire planet. Right now, scientists are racing to understand the aftermath of the magnitude 8.8 megaquake off Russia's Kamchatka Peninsula, a seismic event so extreme it shifted Earth's axis, measurably altered our rotation, and changed the length of our days. The energy unleashed was equivalent to hundreds of millions of tons of TNT, enough to trigger distant volcanic eruptions and disrupt the fundamental stability our entire world depends on. If a single megaquake can tilt the planet and undermine systems like GPS, communications, and even weather, what else is at risk beneath our feet? The story of how a magnitude 8.8 megaquake changes. Everything begins with the forces locked deep below Earth's crust. Deep beneath the Kamchatka Peninsula, two tectonic plates have been locked together for centuries. Along their boundary, the oceanic crust is forced beneath the continental plate in a slow, relentless grind. Every year, millimeters of movement add up, storing energy as the plates refuse to slip. Over decades and centuries, the strain builds until the rocks can no longer hold. When the boundary finally gives way, the result is a megathrust earthquake, unleashing energy on a scale that dwarfs ordinary quakes. The magnitude of an earthquake is measured on a logarithmic scale. Each whole step up means about 32 times more energy released. A magnitude 8.8 event like Kamchatka's is not just a little bigger than a 7.8, it's more than 1,000 times more powerful. The energy released in moments rivals the output of hundreds of millions of tons of TNT, or the electricity used by all of humanity in several months. Geophysical institutes around the world monitor these locked faults with networks of seismometers and satellites. They track tiny deformations in the crust, searching for signs that the strain is reaching the breaking point. But even with the best technology, the exact moment of failure remains unpredictable. When it comes, the rupture can stretch for hundreds of kilometers, releasing a shockwave that ripples through the planet's crust and mantle. The power unleashed by a megaquake is the stored fury of centuries, set free in less than 5 minutes. This is why some earthquakes are felt as minor tremors, while others have the power to shift the axis of the Earth itself. The difference lies in the silent buildup of strain, the locked interface between plates, and the exponential leap in energy that comes with each notch on the magnitude scale. A rupture of this magnitude does not simply break the ground. It tears open the planet's crust for hundreds of kilometers. In the first seconds, seismic energy surges outward in a strict sequence. The fastest, called primary or P waves, race ahead at over 7 kilometers per second, compressing and expanding the rock. These are often felt as a sharp jolt, sometimes mistaken for a distant explosion. Moments later, secondary or S waves arrive, moving at roughly half the speed. Their shearing motion shakes buildings side to side, warping steel and snapping concrete. But the most destructive are yet to come. As the rupture continues, surface waves begin to roll through the upper layers of the Earth. These waves, slower than P and S waves, can travel thousands of kilometers, making the ground heave and sway for minutes. The longest and most violent shaking is often caused by these surface waves, toppling bridges, buckling roads, and reducing entire neighborhoods to rubble. Beneath the ocean, the rupture lifts the seafloor by several meters in seconds. This sudden vertical displacement shoves a massive column of water skyward, launching a tsunami at jetliner speeds. In deep water, the waves can travel at up to 800 kilometers per hour, invisible to ships above. But as they approach the coast, the sea rises into a wall that can reach 10 meters or more. In the 2011 Tohoku earthquake, tsunami waves topped 40 meters in some places. The water carries away everything in its path: cars, homes, entire towns, leaving only debris and silence behind. A megaquake's violence is not contained to the epicenter. Its waves ripple out, shaking distant cities, crossing oceans, and setting off alarms on every continent. The damage unfolds in layers. First, the unseen P waves, then the shaking of S waves, the rolling devastation of surface waves, and finally, for those near the sea, the deadly arrival of the tsunami itself. In the early hours of December 26, 2004, the world witnessed one of the deadliest disasters in modern history. A magnitude 9.1 earthquake struck off the coast of Sumatra, Indonesia, sending shockwaves through the Indian Ocean. Entire villages vanished beneath the water. More than 220,000 lives were lost across 14 countries. The land itself shifted. Some regions moved by over 2 meters in a matter of seconds. Families were asleep when the ground began to roar. In many places, the first warning was the sound of walls collapsing, followed by the relentless rush of water. The devastation was not just measured in lives, but in livelihoods. Ports, power lines, roads, and entire economies were swept away. In 2010, Chile faced its own nightmare. A magnitude 8.8 earthquake struck near Concepcion, toppling cities and costing billions in damages. The Earth's crust leapt forward, shifting the coastline and leaving scars still visible from space. The following year, Japan endured the Tohoku disaster. Towns were erased, and the economic shock rippled worldwide. Survivors describe a night that never seemed to end. Sirens, darkness, and the smell of dust and salt. In the aftermath, the true cost is counted not only in buildings lost, but in the silence left behind. Electricity vanishes in an instant. Power grids fracture along hundreds of kilometers, plunging entire regions into darkness. Transmission towers buckle, transformers explode, and substations collapse under the relentless shaking. In Kamchatka, engineers work through the night, but the sheer scale of the damage means weeks, sometimes months, before the lights come back on. Hospitals switch to backup generators, but fuel supplies are limited and roads are impassable. Water treatment plants grind to a halt. Without electricity to pump or purify, clean water becomes scarce within hours. Pipes burst beneath twisted streets, flooding neighborhoods while leaving others bone dry. Ports, the arteries of global trade, are crippled. Gantry cranes topple, docks split open, and container stacks tumble into the sea. With shipping lanes cut off, vital goods, food, medicine, fuel, are stranded offshore. Airports close as runways crack and navigation systems fail. Highways buckle, bridges collapse, and rail lines are warped beyond use, trapping entire towns in isolation. Emergency crews scramble to clear debris, but every route is blocked by landslides or flooded by broken levees. Industrial zones face their own crises. Chemical plants and refineries leak toxic clouds after containment systems fail. Fires erupt where gas lines have ruptured, spreading unchecked through blacked-out districts. The entire supply chain seizes up, factories idle, warehouses empty, and grocery store shelves go bare. For millions, the familiar rhythms of daily life dissolve into chaos, as the systems they rely on unravel, one after another. Within hours of the Kamchatka rupture, volcano monitoring teams scrambled across the peninsula. Their sensors, ranging from satellite radar to gas detectors, picked up a surge of activity. INSAR satellites mapped ground deformation, revealing bulges and fractures near dormant cones. GRACE gravimetry detected mass shifts beneath the crust, hinting at magma on the move. At Klyuchevskaya Sopka, gas emissions spiked. Sulfur dioxide and carbon dioxide levels doubled, signaling fresh pathways opening deep underground. Field geologists reported tremors and new fumaroles at multiple sites. The earthquake's shockwaves had not just shaken the land, they had transferred stress into the volcanic arc, pushing primed magma chambers closer to eruption. Several volcanoes erupted in rapid succession, a rare chain reaction last seen centuries ago. Scientists debated whether these eruptions were inevitable or triggered by the quake's dynamic and static stress. The data pointed to a planet still shifting, its response unfolding in real time, with every satellite pass revealing new deformations and risks yet unmeasured. Even with the world's most advanced seismic networks, the planet remains riddled with blind spots. Along the Kamchatka Trench, entire stretches of the seafloor are monitored by only a handful of GNSS buoys, leaving vast distances where crucial movements go undetected. Satellite data arrives in bursts, sometimes hours after the fact, while undersea cables relay only fragments. In the aftermath, scientists from Russia, Japan, and the United States rush to compare models, but their predictions diverge. Some suggest the axis shift is twice as large as official figures. Others warn of hidden aftershocks beneath the Pacific. These gaps feed uncertainty, fueling heated debates in international science bodies over how to share real-time data and where to invest in more sensors. Policymakers argue over budgets while the ground itself keeps moving. The megathrust event has exposed not just the limits of technology, but the urgent need for global coordination. Without a denser web of sensors and open data, the next megaquake could catch everyone in the dark. In 2011, a single earthquake shifted Earth's axis by 17 centimeters and shortened our day by almost 2 microseconds. The recent magnitude 8.8 quake off Kamchatka produced similar, measurable changes, confirmed by satellite data and global observatories. Looking back, the 2004, 2010, and 2011 megaquakes caused hundreds of thousands of deaths, multi-billion-dollar losses, and permanent land shifts up to 2 meters. But now, scientists have documented that these events can also alter the planet's rotation and pole position. Despite decades of research, questions remain about how stress transfer might trigger further disasters and how gaps in seabed monitoring leave us partly blind to what comes next. What is certain? Our world's infrastructure, communications, and even the length of our days are vulnerable to forces deep below the surface. As official reports confirm, a single megaquake has the power to reshape both our landscapes and our understanding of stability. This changes everything we thought we knew about how powerful earthquakes can reshape our entire planet.